cover with the PowerPoint presentation, and in last part, okay, I will go with the. So this part already we have covered. Okay, Dirac delta function, ways of using age distribution information, linear process that we have covered now. All first order reactions are linear in nature, because what is the equation of first order reaction? Minus RA is equal to K into CA. So their rate of reaction is proportional to concentration, na? And that's why rate of reaction is proportional to concentration. So every reaction means what? It may be parallel reaction, it may be series reaction, it may be reversible reaction, it may be irreversible reaction. So every first order reactions, okay, is known as linear process. If reaction is not like first order, means minus RA, rate of reaction is not proportional to concentration, then that reaction is known as non-linear process or non-linear reactions. Okay, so for non-linear processes, we have to use flow pattern must be known. आपल्याला फ्लो पॅटर्न माहिती पाहिजे. हा प्रश्न घेतला विचारला होता. If reaction is non-linear, what we require? If reaction is non-linear, we require flow pattern. Flow pattern in the reactor we must know, and plus we have to use model. One mathematical model is there, which we'll discuss at the end of this chapter, dispersion model or Tankin series model. Okay, that we have to use if process is non-linear. If process is linear, mathematics is very simple, steps are very simple, derivations are very simple. But if process are non-linear, then mathematics or steps become very complicated. In generally linear process we have for graduation level, and for higher education, for PG and PhD, we are having non-linear process in non-ideal flow. Then we will discuss next point, linear system with flow model. Linear system with the flow model. Okay. So first very important part we have discussed in last lecture, variance म्हणजे काय? Sigma square. What is the unit of variance? Minute square or second square. And means what? Theta bar or T bar. Theta bar or T bar. What is the unit of theta bar or T bar? Second or minute. Okay. So variance and means are additive in nature. म्हणजे काय? 3 अधिक 2 5. I will also draw diagram. One simple diagram I will draw. Means suppose we are having number of reactors. Variance for reactor number 1 is 2. Variance for reactor number 2 is 3. Variance for reactor number 3 is 2. So 2 plus 3 plus 2, 7. So variance we can add simply. आपण variance एकमेकांमध्ये add करू शकतोय simply. Similarly for means. Suppose we are having 3 reactors. Mean residence time, MRT, we have discussed last lecture. Mean residence time for first reactor is 5. Mean residence time for second reactor is 10. And mean residence time for third reactor is 5. So we can add simply mean residence times. So 5 plus 10 plus 5. So 20 is the total mean residence times for whole system. So it means variance and means are additive in nature for closed vessel. आता closed vessel म्हणजे काय पण समजून घ्या. This question also they are asking in your campus interview. Closed vessel means what? Vessel, simple vessel or reactor in which input is by plug flow and output is by plug flow. असं व्हेसल, असं reactor की ज्यामध्ये input plug flow and output is also plug flow. That vessel is known as closed vessel. आपल्या डोक्यामध्ये काय असते? क्लोज्ड वेसल म्हणजे काय? झाकलेलं वेसल असं नाहीये. In reaction engineering, closed vessel means what? Both input and outputs we are having plug flow. That vessel is known as closed vessel. We are getting or not? Okay. Then also we can define linear process. I told la linear process. So how we can define? Difference in response. Response म्हणजे काय? Output. Divided by difference in stimulus means what? Input. Difference in input is equal to K. म्हणजे काय? Actually, practically means suppose we are having input is 2, output is 1 unit. For example, you can take any unit. Input is 2 and output is 1. If I double input 2 to 4, if I double the input 2 to 4, then automatically output also get double. If I triple input, then output also get triple. म्हणजे त्या रेशो मध्ये बदलत जाते. एकपट, दुप्पट, तिप्पट. You are getting or not? Okay, that process are known as linear process. If you increase input, automatically in the same ratio, output will increase. If I double the input, output will get doubled. If I triple the input, output will get tripled. You're getting or not? So these types of reactions are known as linear process. So what I told, all first order reactions, series, irreversible, parallel reaction, reversible reactions are linear process in nature. For linear process with flow model, we need आपल्याला काय लागतंय फॉर लिनियर प्रोसेस विथ फ्लो मॉडेल. आता आपण वी आर गोइंग टू द नेक्स्ट टॉपिक, लिनियर प्रोसेस विथ फ्लो मॉडेल. आपल्याला काय लागतंय, वी नीड ट्रेसर इन्फॉर्मेशन. म्हणजे काय, आपल्याला स्टिम्युलस रिस्पॉन्स मेथड, स्टिम्युलस रिस्पॉन्स एक्सपेरिमेंट आपल्याला करावा लागतो. And in stimulus response method, what we are getting at the end we are getting concentration time data at different time. As I told in last lecture na, at different times, concentration time 0, 5, 10, 15, 20 like that. Okay, what is the concentration of the tracer in exit that we require? That is known as tracer information. Plus we require kinetic data. Kinetic data means what? In CRE1 you have discussed na, kinetic data means what? Kinetic data means what? Order of reaction, N. K means what? K म्हणजे काय? Rate constant. Okay, so that we require, and then only we can explain that vessel as a reactor. Then only that vessel we can design as a reactor. काय काय लागतंय हे प्रश्न कॅम्पसला विचारतात, गेटला विचारतात. पहिले 3 चॅप्टर तुम्हाला गेट एक्झाम करता आहेत म्हणून समजून घ्या. मी तुम्हाला सांगायला गेटला मला अनुभव आहे, बऱ्यापैकी 4 वेळा बसलो म्हणून सांगायला तुम्हाला की linear process with the flow model we can explain. For that we require 2 things in our hand. पहिली thing काय, we require tracer information. Means what? Stimulus response experiment. I have explained last lecture na, that data we require, concentration time data we require, and plus we require kinetic data. Means what? Kinetic data means what? K, order of reaction. K means what? Rate constant we require, and then only that vessel we can explain as a reactor. You are getting or not? Okay. So after this all general topic, I will move to the one small derivation. The theoretical part of the derivation I will cover first. So conversion, a very important derivation they are asking from in your examination, final examination. So conversion directly for tracer information. So this topic we have to start like this. From tracer information we can find out conversion in the reactor. आपल्याला बाकी काय, डिझाइन ऑफ reactor म्हणजे काय, प्रणाली. डिझाइन ऑफ reactor means what? To find out conversion in given reactor. To find out conversion in the given reactor. बाकी काही नाही. Design of distillation column means what? To find out number of trace in distillation column. Design of heat exchanger means what? To find out heat transfer area, pressure drop in heat exchanger. Design of pump means what? To find out power required for the pump. Similarly, design of reactor means ultimately it comes to conversion in the reactor, in the given reactor. Okay, so conversion in the given reactor we have to find out. Okay, so that is our main aim, and this topic only holds for first order reaction, because first order reactions are linear in nature. First order reactions are linear in nature, so we can find out that only in the first order reaction. You are getting or not? So like that we will go for one small derivation. So this derivation only holds for first order reaction. Okay, so variety of flow patterns can give same tracer informations. In reactors we are having many types of flow patterns, but that same flow, different flow patterns can give same tracer information. Concentration time data जो मिळवतो आपण tracer information म्हणून, it may be same for different flow patterns. Hence, in the design of reactor we have to select such a flow pattern. आपण असा flow pattern निवडायचा which should match with real reactor. आपण एक्सपेरिमेंट करताना काय करतोय, लॅब स्केलला असे एक्सपेरिमेंट मध्ये पॅरामीटर निवडतोय की जो काय प्रॅक्टिकलशी मॅच झाला पाहिजे. सो सिलेक्ट सच अ फ्लो पॅटर्न, सिलेक्ट which should match with the real reactors. If real reactors is having plug flow, you select plug flow. If real reactor is having mixed flow, you select mixed flow. Okay, then we have to go for some assumptions. No intermixing of fluid. First assumption is no intermixing of fluid. Fluid से intermixing होत नाही म्हणजे काय, plug flow. Age distribution of element in exit, telling how long each element remains within the reactor. So age of each element we are having. म्हणजे काय, age means what? That element remain in the reactor for how much time? That age we are having with us. Okay, age distribution of element in exit, telling how long each element remains within the reactors. Getting or not? So for how much times element remain in the reactors, okay, that data we are having in our hand. एवढं आपल्याला सगळं माहिती आहे. Then equation can be solved graphically or numerically. आपण equation आपण ते solve करायचं आहे. We will discuss that later on. Okay, can be solved graphically or numerically if RTD and rate constant of reactor should be known. हा प्रश्न पण गेटला विचारला. We can find out conversion directly from the tracer information. For that, we require this data, data. We require RTD and rate constant. RTD means resident time distribution and rate constant means what? Key of the reactors should be known to us. You're getting or not? This is the theory of the derivation I'm covering. Okay, now actually I will go for derivation. Before going for derivation, okay, I will go for some models, just introduction of. So we are in the actually last part of the chapter, but azun bharpur derivations घ्यायचे आहेत. Lots of derivations are there that I will cover with the blackboard. Okay, but I will move to the some models. So models for non-ideal reactors. So in our syllabus we are having two models. Model number one is dispersion model, which is also known as dispersion plug flow model, which is also known as dispersion plug flow model. Getting or not? And second model is there, which we will discuss in our syllabus, Tankin series model. Okay, so other models are there, but in our syllabus we are having only two models. त्यामुळे तुम्हाला लक्षात ठेवा, आणखी तुम्हाला कोणी काय सांगितलं काय केलं तर दुसरी मॉडेल करायची आपल्याला गरज नाही. We have to only go for two models we are having in our syllabus, dispersion model or second model is Tankin series model. Because these models are very simple to treat. And whatever models are there, two parameter model, multi-parameter model, we will discuss in the higher education, MTech or PhD. Okay, so for our graduation level, this is sufficient for us. Just we will go for fundamental models, basic models, and these models are known as one parameter model. त्या मॉडेलला काय म्हणायचं? वन पॅरामीटर मॉडेल. आता पहिला प्रश्न, why these models are known as one parameter model? Because these both the models depends upon only one parameter. You know, variables are there, temperature, concentration, pressure. तशीच काहीतरी variables असतात. Okay, these models use some variables or some parameters, and that parameter or that variables are only one. For example, dispersion or dispersed plug flow models depends upon vessel dispersion number. Maximum questions you are getting in your GATE examination on this number, vessel dispersion number. After this lecture, to vessel dispersion number, I will call VDN. VDN manna. VDN means is a short form, vessel dispersion number. Okay, and second is Tankin series model. In that, one parameter on which that model depends is capital N. Capital N means what? Tankin number of CSTR in series. Number of equal sized CSTR. So ultimately what I'm telling you, first model is for plug flow and second model CSTR, I'm using what CSTR, second model is for mixed flow. So one model we are learning for plug flow and one model we are learning for mixed flow. We're getting or no? So like this we will go for first model dispersion plug flow model and second model Tankin series model. Dispersion model depends upon only one parameter. That's why this model is known as one parameter model. And what is that one parameter? Vessel dispersion number. Similarly, Tankin series model depends upon only one parameter, capital N. We will discuss that later on. Okay. So capital, what is mean by capital N? Capital N means equal size CSTR in series. CSTR means what? MFR, mixed flow reactor. So first model is for a plug flow reactor. Second model is for mixed flow reactors. Okay, in dispersion model or in dispersion of plug flow models, we are going for some assumptions. पहिलं कुठला assumptions लक्षात ठेवा. पहिला assumption, no stagnant pockets. म्हणजे stagnant pockets नाही आहेत, सगळं मूव होतं. नो बायपासिंग, आपण शिकलो ना बायपासिंग म्हणजे काय पहिल्या लेक्चरला. नो बायपासिंग, नो शॉर्ट सर्किट, नो रिसायकलिंग, नो डेड झोन. आपण शिकलोय की सगळं. So ideal condition, we are assuming ideal condition, ideal situations. So plug flow at one extreme and mixed flow at other with changing treatments. Reactorच्या सुरुवातीला काय आहे? Plug flow and at other extremes we may have mixed flow. Okay. Now this model use fixed first law. Fixed first law we have discussed in mass transfer 1 na. So you know Fick's first law. What is the Fick's first law? J is equal to J म्हणजे flux is equal to minus DAB dCA by dZ. J means flux minus DAB means what? Diffusivity coefficient. dCA means difference in concentration. dZ means distance, difference in distance. Okay. So this dispersion flux flow model uses Fick's first law of the diffusion and one another parameter is axial dispersion coefficient. D, capital D. Axial dispersion coefficient, capital D. कन्फ्युज होतात ना मुलं, लक्षात ठेवा. डी म्हणजे बऱ्याच वेळा मुलांना डिफ्युजिटी वाटते, पण इथं आपण काय वापरणार आहे? कॅपिटल डी मीन्स व्हॉट? ऍक्सियल डिस्पर्शन कोएफिशिएंट. सो व्हॉट इज मीन बाय ऍक्सियल? ओके, व्हेन रिएक्टर इज देअर इनसाइड द रिएक्टर्स, ओके, मोमेंट इज देअर ऍक्सियली अशी असते, और मोमेंट इज देअर रॅडियली अशी असते, रॅडियली. ओके, सो कोएफिशिएंट, डिस्पर्शन कोएफिशिएंट विच गिव्स डिस्पर्शन इन ऍक्सियल डायरेक्शन, अशी म्हणजे ऍक्सियल अशा म्हणजे अशा याच्यामध्ये axial direction, that is known as axial dispersion coefficient. And a dispersion coefficient which gives dispersion radially, asa reactor hai radially, okay, that is known as radial dispersion coefficient. But we will focus only on the axial dispersion coefficient, capital D, which characterize degree of back mixing during the flow. तो काय देतो? डी काय देतो? हा पण प्रश्न गेटला विचारला होता. डी gives degree of dot dot dot. D gives degree of back mixing during the flow. When flow is there, how much back mixing take place? माग परत लिक्विड किती येते? Okay, that we are getting by D, capital D, which is known as axial dispersion coefficient. याच्यावर डेरिवेशन आहे पुढे, लक्षात ठेवा. भरपूर डेरिवेशन, अजून काय चॅप्टर संपलेलं नाही, भरपूर आहे. मी सोपा पार्ट कव्हर केलाय, अजून डेरिवेशनचा पार्ट मी कव्हर करायचा आहे. ओके, दॅट आय विल डू विथ द चॉक अँड बोर्ड. ओके, बट लेट मी फिनिश थ्योरेटिकल पार्ट. ओके, देन axial mixing diffusion due to velocity gradient. हा प्रश्न पण गेटला विचारला होता की ऍक्सियल डिफ्युजन, ऍक्सियल मिक्सिंग जे होतं डिफ्युजनचं, ते कोणामुळे होतं? सो इन द रिएक्टर ऍक्सियल मिक्सिंग इज देअर ड्यू टू वेलोसिटी ग्रेडियंट, and radial diffusion due to molecular diffusion. बघा, मी फार महत्वाचा हे प्रश्न प्रत्येक वाक्य गेटला त्यांनी विचारलंय, गेट एक्झामला, कॅम्पसला विचारतात, समजून घ्या. इन रिएक्टर देर हॅव्हिंग टू टाइप्स ऑफ मिक्सिंग. ऍक्सियल मिक्सिंग म्हणजे ऍक्सिस मध्ये असं, रेडियल मिक्सिंग म्हणजे रॅडियली असं, सेंटर पासून रॅडियली असं. सो ऍक्सियल मिक्सिंग कशामुळे होतोय? ऍक्सियल मिक्सिंग वी आर गेटिंग ड्यू टू द वेलोसिटी ग्रेडियंट. वेलोसिटी ग्रेडियंट मीन्स व्हॉट? डिफरन्स इन वेलोसिटी डिवाइडेड बाय डिफरन्स इन डिस्टन्स. अँड रॅडियल डिफ्युजन ड्यू टू द मोलिक्युलर डिफ्युजन, म्हणजे आपण फिक्स लॉ शिकलो ना आपण, mass transfer 1. Okay, so radial diffusion takes place only due to the molecular diffusion only. Okay, depending upon that, this model depends upon one number, VDN. तुम्हाला म्हणलं ना, VDN म्हणजे काय? Vessel dispersion number. In your campus interview, maximum questions you are getting on this topic, because VDN means what? Vessel dispersion number. Okay, it is dimensionless number. पहिला प्रश्न विचारला, डायमेन्शन काय असते वेसल डिस्पर्शन नंबरचं? तर त्याला डायमेन्शन नाही, हा नंबर आहे फक्त. In name itself, we are using word number na. So number means what? It is just number, no dimension, no units. Okay, and this is the only one parameter on which this model holds. This model depends. Okay, so this parameter you must know by heart. So काय parameter है? Vessel dispersion number. How we can define? Okay, here in PPT you will get that D by UL. D by UL. So what is mean by D? D means this axial dispersion coefficient. I have defined above. मी this define केला ना. U means what? हे पोरांना सांगता येत नाही कॅम्पसला किंवा एक्सटर्नलला. D by UL पण त्यांना माहिती नसते. D by UL is the vessel dispersion number, and D is axial dispersion coefficient. Capital D is the axial dispersion coefficient. Capital T. U is the velocity in meter per second, and L is the length of the reactor. The reactorची लेंथ किती? आता युनिट बघा की D म्हणजे काय? ऍक्सियल डिस्पर्शन कोएफिशिएंट युनिट पर मीटर स्क्वेअर पर सेकंड असते. And what is the unit of UL? U is meter per second. L is meter. So meter by second divided by meter by second. So both get cancelled na. So it is a dimensionless number. You are getting or not? This model is useful for plug flow. मला मी काय सांगितलं मगाशी? पहिलं मॉडेल is useful for plug flow. Hence useful for packed bed and tubes. Hence to find out conversion. या मॉडेलला आपण काय करतोय अल्टिमेटली? तुम्हाला मी नेहमी म्हणतोय, आपल्याला ऍप्लिकेशन माहिती पाहिजे. की आपल्या गॅलेक्सीला वगैरे आपण नुसतं थेरी करून माहित नाही, पण हे सगळे मॉडेल का शिकायचे आपण? बाय दिस मॉडेल वी आर फाइंडिंग आउट कन्वर्जन. डिझाईन करतोय ऑफ द रिएक्टर. वी आर गोइंग फॉर डिझाईन ऑफ रिएक्टर मीन्स व्हॉट? Design of reactor means what? We are finding conversion. We are finding conversion inside the reactor. Okay, so that we are finding out conversion, especially in packed bed and packed tubes. जिथं packing वापरलं जाते लक्षात ठेवा. There generally we are using this dispersion model to find out conversion, to design the reactor, to find out non-ideality in the reactor. You are getting or not? Okay, dimension. Now new parameter I will introduce. Okay, dimensionless variance. I have introduced already variance. Na? Variance means what? Sigma square. But to that sigma square, if I attach theta, theta attach केले बघा, त्याला म्हणायचं dimensionless variance. So what is the definition of dimensionless variance? I will tell you on the blackboard. आता मी सांगतो तुम्हाला, dimensionless variance means variance divided by time square. I will write on the blackboard. Okay, dimensionless variance means what? Variance divided by time square. So what is unit of variance? Minute square. What is unit of time square? Minute square. So minute square get cancels. We are getting what? Dimensionless variance sigma theta. So in your chemical reaction engineering or in any subject, please keep in your mind that if anything is having theta, suffix theta, that is dimensionless parameter. T theta, which is dimensionless time. C theta, पुढे लागणार आहे आपल्याला, पुढे आहे डेरिव्हेशन आहे, या चॅप्टर मध्येच आहे. C theta mean dimensionless concentration. V theta, V mean volume. Theta, it is having suffix theta na, so dimensionless volume. You are getting or not? So like that, we are having, if theta is having suffix, okay, that parameter become dimensionless 100%. Okay, is important in this model. You are getting sigma theta square is equal to sigma square divided by t bar square. This is a dimensionless variance. It becomes important in this model. If back mixing is larger, or reactor is not closed, model is not useful. म्हणजे काय बघा, back mixing म्हणजे काय, पाणी असं उलटं लक्षात ठेवा. Back mixing, you are getting or not? Turbulence. Okay, if it is larger, हे जर जास्त असेल लक्षात ठेवा, तर काय होतंय? Back mixing is more mean turbulence. पाणी असं उलटं फ्लॅश होणं वगैरे असं असेल, then this model is not useful. हे पण प्रश्न कॅम्पसला विचारतात. Then this model is not useful. If back mixing is there, if turbulence is there, if vortices formation is there, this reaction is not useful. Even this model is not useful when reactor is not closed. तुम्हाला मी प्रणाली परत सांगते, क्लोज म्हणजे काय? बंद reactor नाही. Reactor in which input is by plug flow and output is by plug flow, that reactor is known as closed reactor. You're getting or not? Okay, so if reactor is not closed, if back mixing is there, this model is not useful. You're getting or not? Okay, now I will go for significance of VDN, vessel dispersion number, which they are asking very frequently in your GATE examination. Even in your industry we require that. How to find out vessel dispersion number. पुस्तकात दिलेलं नाही आहे, it is from Davandi book. It is not in Octal Level Spill book. So please try to get it. Please, whatever important points are there, please write down. You are in the very important year, Sahil, final year, which is your key year, important year for your whole career. So whatever important I am telling you, just write down, please. Or you can also make screenshot. But it is better to extract notes. You're getting or not? So significance of VDN. So how we can define VDN? D by UL, where D is axial dispersion coefficient. सांगितलं, हे माहिती पाहिजे. कोणाला ओरलला सांगता येत नाही, कॅम्पसला सांगता येत नाही. हा, वेसल डिस्पर्शन नंबर काय 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 कोणाला येतच नाही, काय काय मुलांना येते डी बाय युएल. पण डी म्हणजे काय, यू म्हणजे काय, एल म्हणजे काय सांगता आलं पाहिजे. मी सारखं परत परत सांगायला लागलोय. डी मीन्स ऍक्सियल डिस्पर्शन कोएफिशिएंट विथ युनिट मीटर स्क्वेअर पर सेकंड. यू मीन्स व्हेलॉसिटी. एल मीन लेंथ ऑफ द रिएक्टर. ओके, हाऊ वी कॅन रिअरेंज दॅट. इथं बघा प्रणाली सुदर्शन तुम्ही कसं केलं बघा. दिस सेम आय कॅन राईट डी बाय युडी ना, डी बाय युडी इंटू डी बाय एल. So d get cancelled, d get cancelled, and again we are getting d by ul na. So d by ul I can write like this. So here d is again axial dispersion coefficient, u is velocity, and what is the d small d? A small d काय आहे? हा diameter आहे लक्षात. Diameter of reactor. Okay, into diameter divided by length of reactor. You're getting or not? So then here d by ud. हा प्रश्न बराचसा विचारला. डी बाय युडीला म्हणायचं इंटेन्सिटी ऑफ डिस्पर्सिंग. डी डिवाइड बाय व्हेलॉसिटी इंटू डायमीटर ऑफ द रिएक्टर, त्याला काय म्हणायचं? इंटेन्सिटी ऑफ डिस्पर्शन, इंटेन्सिटी ऑफ डिस्पर्सिंग. प्रॉपर वर्ड इज इंटेन्सिटी ऑफ डिस्पर्शन. आणि स्मॉल डी बाय एल काय आहे दुसऱ्या ब्रॅकेट मध्ये? स्मॉल डी काय आहे? It is diameter of the reactor. L, what is L? Length of reactor. So these are the geometric factor, na? So these are the geometric factor. So how we can signify, how we can explain vessel dispersion number? Vessel dispersion number is equal to intensity of dispersion. कारण d by ud काय आहे? Intensity of dispersion into small d by l म्हणजे काय? Geometric factor. So d by ul depends upon which parameter? Geometric factor and intensity of dispersion. That is the practical significance of vessel dispersion number. D changes, it changes. L changes, it changes. You are getting or not? Okay. So d by ul is intensity of dispersion and small d by l is geometric factor. Last very important sentence about this model. इथं derivation आहे, मी घेतलेलं नाहीये, पण simple theoretical part मी संपवलेलो आहे. But okay, so I will go for derivation with chalk and board. Okay, but in simple part today I will try to complete. Okay, very important part. If d by ul is 0, if d by ul is 0, Sudarshan, mean d 0 na? D 0 means axial dispersion coefficient is 0. If axial dispersion coefficient is 0, mean we have plug flow. काय असतो? Plug flow असतो लक्षात. If d by ul is infinity, means d by ul is infinity means what? D is maximum. D is maximum म्हणजे काय? Dispersion coefficient is maximum. Dispersion coefficient is maximum. Reading or not? If dispersion coefficient is maximum, then in the reactor it gives mixed flow. हा प्रश्न पण बऱ्याच वेळा विचारले, लक्षात ठेवा कॅम्पसला गेटला वगैरे. In dispersion model or in the reactor, if vessel dispersion number approaches to 0, we get dot flow in the reactor, plug flow. If d by ul approaches infinity, we get mixed flow. You are getting or not? Okay. So like this, we have covered theoretical part of dispersion model, but still I have to cover derivation. Derivations are there, which I will cover after covering the theoretical part of next topic. So next topic is chemical reaction and dispersion. So it is in same topic, same main topic. Chemical reaction and dispersion is in the dispersion model only. As in dispersion model something nahi hai lakshya. Okay, so that, and in this topic we are having derivation. After this topic, after this theoretical part, in same topic one derivation is there. That derivations I will solve with the help of chalk and board. But before that, some theory is there. That theory I will cover with the PPT. So what is the topic's names? Chemical reaction and dispersion. हा प्रश्न विचारता, derive relation for chemical reaction and dispersion. असा प्रश्न विचारला तुमच्या परीक्षेला. मागच्या वर्षी पडला होता. मागच्या वर्षी म्हणजे मागच्या वर्षी ज्यावेळी सब्जेक्टिव्ह पेपर होता पडला होता. To derive relation for chemical reaction and dispersion. So we have to go for these derivations. So we have to start this derivation like this. Consider steady state flow. I will draw diagram on the blackboard. मी diagram करणार सगळं करणार. मला मी सगळं डिटेल मध्ये सांगणार. But before that, consider steady flow reactor of length L. So steady state reactor is there. Mean input is continuously input, continuously output. Length of reactor is L. Fluid velocity is U. Fluid velocity काय आहे? आपण सांगितलं ना, U. Axial dispersion coefficient. Axial dispersion coefficient is capital D. हे सगळं झालं ना, आपल्याला माहितीच आहे की. Then we will consider reactor. What is the reaction? A gives product. First simple reaction घेतली बस. अवघड reaction घ्यायची नाही derivation. Yeah, this is we are studying graduation level syllabus. So take simple reaction. A gives R or A gives product. With rate equation, what is the rate equation? Minus R is equal to K into C raised to N. तर वर मी करू शकत नाही, म्हणून मला ते असं मी लिहिलं लक्षात ठेवा. काय ते minus R is equal to from CRE1, you know, minus R is equal to K into C raised to N. Okay, you know from CRE1 this is the rate equation for A gives product reaction. Okay, now from CRE1 again you know that what is the material balance. Material balance you have studied in 5th chapter of CRE1. बघा 5व्या चॅप्टर मध्ये material balance शिकला होता बघा. एक लहान चॅप्टर आहे रॉक केमिस्ट्री मध्ये. So what is the material balance? Material balance म्हणजे काय? आपण जे इनपुट घालतो रिएक्टर मध्ये, it is we are getting as output. बरोबर आहे? That we are getting as output or some part may get disappear. काही पार्ट काय होतो? Disappear होतो. And some part will get accumulated. रिएक्टर मध्ये accumulate होतो. आपण शिकलो की सगळे लक्षात ठेवा. Okay, so it gives that conversion XA depends upon K tau and vessel dispersion number and reaction order. ही सगळ्या शेवटची लाईन आहे. ह्याच्यामध्ये डेरिव्हेशन आहे. डेरिव्हेशन मी घेणार आहे, पण त्याच्या अगोदर फक्त मी एवढं सांगतो. At the end of this topic, we are getting that काय होतं एक वी आर गेटिंग वन इक्वेशन आफ्टर डेरिवेशन. Okay, and what that equation suggests, that equation tell us that conversion XA conversion depends upon K tau. K म्हणजे काय? रेट कॉन्स्टंट. टाऊ म्हणजे काय? पेस टाइम. मला सांगणार आहे पेस टाइम म्हणजे काय, सगळं सांगणार आहे पेस टाइम. तुम्ही शिकलाय पेस टाइम, पेस व्हेलॉसिटी सीआरई 1 ला शिकलाय. तुम्ही मला सांगितलं पाहिजे. If anyone is having answer of page time, then he can put in the chat box. I will check. Okay, so tau is space time. शिकलाय की नाही पेज टाइम पेज व्हेलॉसिटी इन सीआरई 1. VDN is vessel dispersion number and reaction order n. You know order of reaction is n. Always we are saying by n. Okay, so at the end of these derivations, we are giving that conversion depends upon three parameters: k tau, vessel dispersion number, and reaction order n. तर ह्यामध्ये अतिशय महत्वाचा भाग पोरांना येत नाही. के टाऊ म्हणजे काय? is a rate constant, tau is a base time, and that group is known as Damclor number. पुस्तकात दिलेलं नाही आहे. In octave spill it is not given. Hence students are unable to tell answer of this point. This k tau you will get in दवंडे book. दवंडे book मध्ये दिले बघा. मुलांना एक्सटर्नलला कॅम्पसला विचारता डॅम्प्लोर नंबर म्हणजे काय? तर डॅम्प्लोर नंबर म्हणजे काय? It is in this topic. And how we can define Damclor number? Damclor number is equal to k into tau. मुलांना हे पण येते, पण ते के म्हणजे काय टाऊ म्हणजे काय सांगू शकत नाही. तर के म्हणजे काय? रेट कॉन्स्टंट. आणि टाऊ म्हणजे काय? पेज टाइम, विच यू आर डिस्कस इन सीआरई 1. परत सांगतोय, तुम्हाला येत असेल तर तुम्ही चॅटबॉक्स मध्ये टाका पेज टाइम म्हणजे काय, सगळ्यांना कळेल. ओके, इट इज देअर इन सीआरई 1. सो के टाऊ इज नोन ॲज डॅम्क्लोर नंबर. स्पेलिंग काय? DAMKOHLR. Damclor number. It is a dimensionless number. Damclor number, and it is very important in design of reactor. When we are using dispersion model, you are getting or not? So VDN is the dimensionless number. K tau is a Damclor number. Again dimensionless number, and reaction order n. You are getting or not? So that's where I have. Okay, just now 10-15 minutes are there, 15-20 minutes are there. Just I will go for theory of the our last model, Tankin series model, and then I will cover all the derivations. ह्या तुम्हाला वाटलं हा चॅप्टर सोपा आहे, नाहीये, अजून मी डेरिव्हेशन घेतली नाहीये. मी थेरॉटिकल सोपा पाठ घ्यायला लक्षात ठेवा. अजून मी डेरिव्हेशनला हात लावलेला नाहीये. On next lecture, I will start derivation. Okay, derivations are very important and difficult also. Okay, especially in this Tankin series model, one derivation I will cover after 2 lectures, maybe after 1 or 2 lectures, which is of 3 pages. 3 पानाचे derivations. Okay, Laplace transfers are there, many derivative integrations are there, lots of things are there. Okay, so you must have strong mathematics to get CRE2. CRE1 मध्ये mathematics is simple as compared to CRE2. Okay, so next model, Tankin series model. आपली थिअरी बऱ्यापैकी कव्हर झाली या चॅप्टरची, पण डेरिव्हेशन कव्हर झाली. लाईक मला अजून चौकाने बोर्डचा वापर करून मला अजून 2-3 लेक्चर्स लागणार लक्षात. देन आय विल स्टार्ट एक्झाम्पल. Okay, graphical example. So during graphical examples, please be with the graph papers. Okay, 7 to 8 example I will try to take. Tankin series model तुम्हाला मी सांगितलं ना, आपण काहीतरी इम्प्रुव्हमेंट करायचे. तुम्हाला प्रत्येक, मी तुम्हाला सांगायला की प्रत्येक टॉपिक आहे त्याचा यूज काय, इंडस्ट्रियल ऍप्लिकेशन काय हे तुम्हाला सांगता आलं पाहिजे. तुम्हाला इतर सब्जेक्टमध्ये पण तुम्ही ते शिकून घ्या. बर्नॉली इक्वेशन आहे, बर्नॉली इक्वेशनचा यूज काय हे तुम्हाला सांगता आलं पाहिजे. ऍप्लिकेशनचं सांगता आलं पाहिजे. तो का शिकतोय आपण हे तुम्हाला कळलं पाहिजे, लक्षात ठेवा. तसंच टँकिंग सिरीज मॉडेल वी आर स्टडिंग. दुसरं म्हणजे काय, तुमचं मॅथमॅटिक्स चांगलं पाहिजे, एक्झाम्पल तुम्हाला सोडवता आलं पाहिजे. आपली मुलं थेरीचे क्वेश्चन सोडवतात, एक्झाम्पल सोडवत नाही, लक्षात ठेवा. सो टँकिंग सिरीज मॉडेल is a one parameter model. As I told, it is very common, it is very important for CSTR or mixed flow reactors. It represents non-ideality in the reactor. What it gives this model, आपण काय यूज करतोय, ह्या मॉडेल पासून आपल्याला कळतंय की हाऊ मच नॉन आयडियलिटी इज देअर इन द reactor. Plus from this model we are getting conversion. बस दोनच application आहे, industrial application. By these two models we are getting extent of non-ideality and we are getting conversion in given reactor by both the models. First model we are using for plug flow, second model we are using for mixed flow. Okay, so this is a one parameter model, just like previous models. Okay, to represent the non-ideal flow. So what is one parameter? So here one parameter is series of equal size stir tank. Hey, second sentence, series of equal size stir tanks and number of tanks in series. N, capital N, मी दाखवलं नाहीये, capital N. Capital N is वापरायचं in this model, in this chapter. So capital N means what? Number of equal size CSTR in series. You're getting or not? Okay, this is the only one parameter of this model. That's why this model is known as one parameter models. आता तुम्हाला बऱ्याच वेळा विचारतात की compare this model with previous model. Which one is better? Generally for plug flow, पहिला point. Generally for plug flow, dispersion model. For mixed flow, Tankin series model. Second point, dispersion model is complicated. Tankin series model is simple to use. Dispersion model is less common, but Tankin series model is more common in industry. Plug flow is less common. In dispersion model is less common, but mixed flow is very common in the industry. Hence, Tankin series model is very common in the industry. Next, models are easy to use. Tankin series model. Models are difficult to use. Dispersion model. In dispersion model, boundary condition are fixed. Dispersion model मध्ये boundary condition दिलेले असतात. But in Tankin series model, no boundary conditions are required. लागतच नाही. Simple झालं ना? Boundary conditions नसतील तर लक्षात ठेवा. Next, in dispersion model, we have required tracer information. Stimulus response technique experiment करावा लागतो. पण Tankin series मॉडेलला तो एक्सपेरिमेंट करायची गरज नाहीये. स्टिम्युलस रिस्पॉन्स टेक्निक एक्सपेरिमेंट आपण मागच्या वेळी दाखवला होता ना, तो करावा लागतो, पण याला करावा लागत नाही, लक्षात ठेवा. यू आर गेटिंग और नॉट? ओके, सो नो क्वेश्चन ऑफ स्टिम्युलस रिस्पॉन्स टेक्निक्स, नो क्वेश्चन ऑफ ट्रेसर इंजेक्शन, नो क्वेश्चन ऑफ ट्रेसर मेजरमेंट. सोपं झालं ना Tankin series model. So which one is better? Tankin series model. So Tankin series model is having a number of advantage over the dispersion model. Okay. So in this model, one final equation is there which I will derive in next lecture after derivations. If the equation सांगतो, this equation is sigma theta square. मग मी काय सांगितलं, सिग्मा थीटा म्हणजे काय? डायमेन्शनलेस व्हेरियन्स. सिग्मा थीटा स्क्वेअर. सो डायमेन्शनलेस व्हेरियन्स सिग्मा थीटा स्क्वेअर. हे दोन मी खाली काय लिहिले, मला ते वर घेता येत नाही, या लक्षात मी ते खाली गेले, पण हे काय आहे ऍक्च्युअली? सिग्मा थीटा स्क्वेअर. सिग्मा थीटा स्क्वेअर इज इक्वल टू 1/n. सिग्मा थीटा स्क्वेअर म्हणजे काय? मी लिहितो ब्लॅकबोर्ड वर. सिग्मा थीटा स्क्वेअर मीन्स व्हॉट? डायमेन्शनलेस व्हेरियन्स. इट इज इक्वल टू सिग्मा स्क्वेअर डिवाइडेड बाय टी बार स्क्वेअर is equal to 1/n. What is meant by n? N means what? Number of CSTR, equal size CSTR. Number of equal size CSTR in the series. Minion. Okay. If हा पुढचा प्रश्न गेटला विचारला होता. If number of n are large, mean number of tanks are in series are large, then E curve becomes symmetrical. हा प्रश्न गेटला कॅम्पसला विचारतात. E curve in CSTR or in Tankin series model when E curve becomes symmetrical. E curve becomes symmetrical in Tankin series model when number of n moves toward the infinity. जसं जसं n वाढतात, number of Tankin series वाढतात, तसं E becomes more symmetrical. n कमी असेल, E become unsymmetrical. उलट त्याच्याबरोबर होतं. This model is, हा प्रश्न पण विचारलाय, this model is useful in treating recycle flow. You know what is meant by recycle? उलट पाठवलं ना, लक्षात ठेवा. To treat that recycle flow, this model we are using generally. In recycle reactor we are using this model. And closed recirculation system. परत तेच आपण recirculation करतो, परत लक्षात ठेवा. For the recycle flow and for closed recirculation systems, we are using this model. Okay. A last theoretical topic of this chapter, okay, that I will cover, and then I will use chalk and board, and I will start detailed derivation from next lecture. But today I will try to cover some remaining part. Okay, that I will diagrams I have to cover. So last part of this, last topic of theoretical topic of this chapter, non-linear flow, is multi-parameter model. मी परत सांगतो, हा चॅप्टर संपलेला नाहीये. या चॅप्टरची डेरिव्हेशन अजून भरपूर आहे, मी घेणार आहे. मी मुद्दाम सोपं घ्यावं की तुम्हाला एकदम भीती वाटू नये, कारण याची डेरिव्हेशन फार अवघड आहे. तुम्हाला कळेल, आपण घ्यायचं आहे पुढे, लक्षात ठेवा. हळूहळू टप्प्याटप्प्याने. पण लेट मी फिनिश सिम्पल पार्ट ऑफ दिस चॅप्टर. सो last topic of this chapter is multi-parameter model. So now we have discussed two models: dispersion plug flow model and second model, Tankin series model. Dispersion model and Tankin series model we have also compared. 5 to 6 comparison points are there. Okay, so dispersion model is more useful for plug flow. Tankin series model is useful for mixed flow. You getting or not? Okay, so like that these models we have na. These models we have. You getting or not? हे models सगळे आपले आहेत, दोन models आहेत लक्षात ठेवा. But these models we can use only to some extent. But when, especially when we are dealing with the multi-phase reactors, multi-phase reactor म्हणजे काय? Reactor in which we are having more than two phases: gas phase, liquid phase, solid phase. That reactors, for example, slurry reactor आपण शिकणार आहे in last chapter of your syllabus. Trickle bed reactor, moving bed reactor, packed bed reactor, tubular reactor, fluid bed reactor, in which we are having two or more than two phases. For that reactor, okay, we can't use one parameter model, Rankine series model or dispersion models. Okay, hence if reactor contains different regions म्हणजे काय तुम्ही शिकलाय की डेड झोन, stagnant pockets, मधीच plug flow, then mixed flow, again plug flow. So combination of flow are there in one reactor only. Okay, interconnected in various way. We may have bypass in same reactor. We may have recycle in same reactor. Yes. Okay, then we have to use multi-parameter models. Mean models which use two or more than two parameters to find out non-aridity in that reactor, to find out conversion in that reactor. आपल्याला दोन किंवा दोनपेक्षा जास्त पॅरामीटर्स वापरावे लागतात, अनलाइक टँकिंग सिरीज मॉडेल और डिस्पर्शन मॉडेल. ओके, फॉर एक्झाम्पल इट डायग्नोज पॅथॉलॉजिकल फ्लो इन द वेसल. इन वेसल पॅथॉलॉजिकल फ्लो आपण मेडिकल टर्म मध्ये आपण म्हणतो पॅथॉलॉजी, त्याकरता सुद्धा हे मल्टी पॅरामीटर मॉडेल आपण लागतात, लक्षात ठेवा. मग गेटला त्यांनी प्रश्न विचारला होता किती पॅरामीटर असू शकतात मॅक्सिमम. Okay, that's why I have taken this next sentence. In multi-parameter models, minimum 2 parameter must be there to maximum 7 parameter. हे समजून घ्या, फार महत्त्वाचं आहे. In multi-parameter model, minimum 2 to maximum 7 parameters are there required to explain this model. And hence, this model is useful for trickle bed, sparger, fixed bed, fluid bed, moving bed, slurry reactor. So some names of multi-parameter models, and I will stop. Okay, presentation I will use chalk and board. नाव तुम्हाला माहिती पाहिजेत ना, एक 3 नाव मॉडेलची तुम्हाला नावं सांगतो फक्त. That models you will get in octet level speed, but just I will go for names of this model, multi-parameter model. First model is short and long time scale model. Short and long time scale model. Second is two region model. Third is hydrodynamic flow model. Third is hydrodynamic flow model. Now I will tell you what is the hydrodynamic flow models. So in hydrodynamic flow models, we are having bubbles. After bubbles, bubbles. Okay, so that is the one phase. Then in that we may have catalyst. That is another phase. Then we may have liquid, in which that catalyst and bubbles suspended. Okay, so 3 phases are there. So this multi-phase reactor is there. So in this we require more parameters to explain this model. For example, we require bubble size, we require superficial velocity of the bubble, we require catalyst size, we require liquid density, we require liquid properties. So number of parameters we require to explain this model, and that's why this model is known as multi-parameter model. You are getting or not? Okay, so second unit is mixing of fluid, that will discuss later on. Before that, let me finish some remaining part of this chapter. Okay, derivation, detailed derivations also get me. Okay, number 1, types of inputs we have discussed. Types of inputs. So that inputs, first input is random input. First input is random input. Types of input, two stimulus response technique. आपण हे केलं ना. रॅन्डम इनपुट म्हणजे काय? कॉन्सन्ट्रेशन आहे. कसे? रॅन्डम. ओके, सेकंड इनपुट साइन. आणि कोणत्या आहे? पाच आहे. पाच रॅन्डम सायक्लिक. Okay, cycling. Again, draw same diagram. Concentration and you know sine waves. You have discussed that sine waves. This is sine wave. एवढं समजून घ्या तो डायग्राम समजून घ्या बाकी काही आपल्याला नॉलेज असतं. ओके थर्ड इनपुट कुठल्या टाइप सायक्लिंग सेम डायग्राम कॉन्सन्ट्रेशन वर्सेस टाइम. सायक्लिंग म्हणजे काय? सायकल ना दिस इज फर्स्ट सायकल, दिस इज सेकंड सायकल, दिस इज थर्ड सायकल. फरक काय लक्षात ठेवा. हे वेगळा आहे, हे वेगळा आहे, हे वेगळा आहे. ये हा कंटिन्यू होता है ना प्रणाली ठीक is later shorter but here cycle is same. Okay, this is the cyclic diagram the stimulus response for input which is important part is कुठला state input कसा state input concentration on y axis time on x axis. Okay, state म्हणजे पाहिजे five biases. Okay, and this is very important thing is this is the one है कहाँ है one है one zero this is state. The last input is there कुठले input है pulse input. मुद्दा में डायग्राम मोटा का दिखा हूँ. Last input is there pulse input. अरे हमें विजिबल ना. ओके what is the pulse input? अरे दिसते ना ब्लैक बोर्ड. अरे whether blackboard is visible to you or not. Okay. Dear, I will stop. Okay. तीर्थराज, is it okay? अरे बाळ तीर्थराज दिसते ना आता?
Yes sir.
ओके मी स्क्रीन शेअरिंग कमी कर बंद केलं. पल्स इनपुट मुद्दा डायग्राम मोठ्या काढायला लक्षात ठेवा. मला दिसणार नाही. पल्स इनपुट हे जास्त डायग्राम मोठ्या काढू शकत नाही. वस्तू तर प्लीज समजून घ्या. अरे यार ओके पल्स इनपुट कसा असतो पल्स अगेन सेम डायग्राम कॉन्सन्ट्रेशन एंड टाइम. पल्स असा बस एवढंच पुढे काय नाही. त्याला माझं पल्स सिमेट्रिक असतात. सिमेट्रिक पाहिजे सिमेट्रिक असतात. सिमेट्रिक करतात. ओके दिस इज पल्स इनपुट. आता हे आउटपुट बघा. आउटपुट प्लस आणि ओव्हर आहे. रँडम इनपुट दिला
Hello sir.
आउटपुट रँडमच असणार ना. अभ्यास कमी केला मार्क पण कमीच पडणार. ओके
Hello sir. Hello sir.
बघा मी काय टाकलं बघा. पण हा इनपुट आहे. दुसरा टाकला हा बघा. इकडे काय महत्त्वाचं आहे. इस इनपुट इज रँडम नॉट विजिबल.
Screen.
आकाश स्क्रीन पिन करा. आकाश मोठे डायग्राम मोठे कर दिला आकाश.
Sir, sharing is still on. Sir.
screen totally stop.
Okay. Input random, output पण random असतं. Next, cyclic. If cyclic input is like this, output असा असतो. वरचा जो कर्व आहे की वरचा कर्व that is input. And lower कर्व is output. आपण सायकलिंग केलं, सायकलिंग म्हणजे सायकल घड्यामध्ये काढा ना, एक सायकल पूर्ण करतो, सायकलचं एक सायकल पूर्ण आपण सायकल इनपुट दिलं, सायकल इनपुट वी हॅव गिवन, आउटपुट इज ऑल्सो सायकल, बट इट्स एम्प्लिट्यूड इज लेस. ते बघा खाली आला आणि इनपुट वरचा मोठा असतो. एवढं असं हे एवढं महत्त्वाचं नाही. साइन सेम तसंच, इफ साइन इनपुट इज गिवन, सायनोसॉइड इनपुट इज गिवन, ओके, वी आर गेटिंग आउटपुट लाइक दिस. हे आउटपुट आहे, तर हे इनपुट आहे. High amplitude and with low amplitude they are having this output. Next, very important, number 4, this is output or step input. Yeah, so the input. This is the input. कसं राहायचं तुम्हाला प्रॅक्टिकल सांगणार आहे. तुम्ही प्रॅक्टिकल आहे म्हणजे कसं राहायचं समजून घ्या. Okay, so this is the input step. What is output? Output is like this. पास आहे त्यावर. कसा लोग आकाश समझ जाता, आकाश कॉर्नर yes yes I will come to you. Please stop sharing this. अरे शेयरिंग स्क्रीन बंद केली की आता केलं काय दिसलं आकाश?
हा सर आता बंद झालं.
ठीक आहे सॉरी बाबा. स्क्रीन शेअरिंग इज स्टिल ऑन सर. ओके आता आकाश दिसते काय?
येस सर. येस सर विजिबल.
हे बघा हे समजलं फार महत्त्वाचं आहे. जे मी तुम्हाला स्पॉट केली विषय हिअर इनपुट कसं आहे स्टेप. व्हॉट इज आउटपुट? आउटपुट कसं आहे बघा हा कर्व असा कर्व दिस इज आउटपुट. और this curve, when step input is there, whatever curve we are getting, na curve is getting. That curve is known as F curve. That curve la काय नाव आहे? F curve. When we are getting step input, this F curve is also known as J theta curve. त्याला आणखी एक नाव आहे J theta curve. समजून घ्या महत्त्वाचं आहे. लास्ट दोन उपवास दुसरे आलेले वाचले. ओके लास्ट वन. पल्स इनपुट. पल्सला आणखी नाव काय आहे? डेल्टा इनपुट. पल्सला आणखी नाव काय आहे? इम्पल्स इनपुट. इट इज व्हेरी कॉमन इन इंग्लिश टू फाइंड आउट non-identity in that. ओके असं की थोडासा this curve is known as when we are getting pulse input. Whatever curve we are getting, generally this curve is symmetrical, but it may be unsymmetrical. Generally it is symmetrical. Okay, but depending upon input it may be unsymmetrical. This curve is known as E curve or C curve or J dash theta curve or RTD curve. RTD curve म्हणायचं. Generally area under this curve is equal to 1. Second when we are getting step input, area under this curve we are getting 1. असते जवळपास you practically will get that. You are getting or not? त्यामुळे समजून घ्या positive conclusion. When step input is there, output is like this. Whatever output we are getting, that output curve is known as F curve or J theta curve. And then we are getting pulse input, which is also known as delta input or impulse input. We are getting curve like this. Area under this is approximately equal to 1, and this curve is known as EC or Z theta curve or RTD curve. ये लागणार आहे आपल्याला लक्षात ठेवा. What we are having on the x-axis, time. And what we are having on the y-axis, concentration, which we are finding in the stimulus response method. We getting or not? So we have discussed so far 5 input method. Past method is on random, cyclic, sinusoidal, Time, state, and pulse. So conclusion is what? Here, these methods we are having for PG level, but as these two methods, state input and pulse inputs, are simple to treat with simple mathematics with less number of steps. Hence, for our graduate level study, only in our syllabus we are having these two methods. Kutle methods? Pulse input and state input. Other three methods are not in our syllabus. This is for your higher education. Last for level, right? I told you dimensionless spread. Kasa so dimensionless spread? Sigma theta. Sigma square theta is suffix. Okay? It is equal to sigma square divided by t bar square is equal to 1 upon Tn. This is a very important parameter to find out non-identity in the tanking series model. This is known as dimensionless spread. Why dimensionless? Sigma square. Dimension is unit square. Time square. Dimension is minute square. Get cancelled dimension. It is equal to 1 by n. The n is number of equal size CSTR in series. Special dispersion number I will write. Special dispersion number is equal to what? D bar UL. D is axial dispersion coefficient. U is velocity of the flow, and A is the length of the reactor. Ready or not? Okay, so this part, diagram part and this formula part is more. Okay, in next lecture I will start with the derivation. Okay, just 1 minute I will give you for question and answering. If you have any questions, answering. Yes. Any question? पन्नासच मुलं आहेत काय अवघड आहे 70 पैकी 50. Yes, any question? अरे क्वेश्चन नाही म्हणून तर रिप्लाय करा बाळांनो. अरे एनी क्वेश्चन? नसेल तर नाही म्हणून सांगा ना, मी बाहेर पडतो मग. आहे का कोणाला क्वेश्चन? अंडरस्टूड. ओके ओके ठीक आहे ठीक आहे. सो आय विल यू 50 स्टुडंट्स आर देअर. बघा अटेंडन्स वाढवायला प्रयत्न करा. 2-3 वेळा सांगणार नाही तर काय. ठीक आहे. कनिष्का. ठीक आहे. थँक्यू. ओके.